All right, guys, hopefully you've already watched us fill in our examples of graphs of rational functions. You have filled out your guided notes for 3.5 over rational functions and their graphs. And now we have some graphing practice for rational functions. We're going to fill out this first page together, and then I want you to stop and do your best on the 4 graphs that follow, and then come back and look at them maybe one at a time to see how you're doing on graphing on your own. Remember, when you have your test, you're not going to have me sitting there walking you through it, and you're not going to have the homework cups on my math lab. All right, first things first. What 2 things do you need to do before you find asymptotes? Before we find asymptotes, we need to check for symmetry. Although, you know what, we kind of do that while we're finding the asymptotes, because sometimes locating those vertical asymptotes can let us know if we've moved away from the origin and the y-axis, then we don't have any predictable symmetry. But for sure, the very first thing you need to do is identify that domain. And before you take your function to lowest terms, you have to identify what values to kick out of the domain, because that tells you whether or not you have holes in the graph. Vertical asymptotes. Where do we find vertical asymptotes? We find vertical asymptotes from zeros in the denominator that don't cancel, because if they cancel out, it represents a hole in the graph. Vertical asymptotes occur where I have zeros in the denominator, values that cause me to have a 0 in my denominator that isn't going to cancel out when I put my function in lowest terms. Can I have more than 1 vertical asymptote? Yes, absolutely. I can have 2 or 3 vertical asymptotes. I don't think I ever give you anything more than 2 though. Can a function cross a vertical asymptote ever? No, you shall not pass. Your vertical asymptote is like a brick wall. When I write the equation of my vertical asymptote, that equation looks like x equals whatever value. Horizontal or slant asymptotes. Where do I look to find the horizontal or slant asymptote? Well, I compare the degree of the numerator to the degree of the denominator. And I look to see if those degrees are less than, equal to, or 1 greater than. Can I have more than 1 horizontal asymptote, or more than 1 slant asymptote, or one of both? No. My horizontal and slant asymptote, its job is to tell me what happens as the function gets, as x gets large, as it goes to positive or negative infinity. And that only goes one way. As x gets large in a positive direction, y either goes up or y goes down. So I can only have one of those. Can a function ever cross a horizontal or oblique, which is another word for slant, asymptote? Well, yeah, it can. It's not going to at the ends because that's the purpose of that asymptote, but it could in the middle. What does that equation look like? Well, my vertical asymptote looks like x equals, so my horizontal or slant asymptote looks like y equals. How do I find my y-intercepts? Well, I set x equal to 0. Can I have more than 1 y-intercept? No, it's a function. It only crosses any vertical line 1 time. And my y-axis is a vertical line. How do I find the x-intercepts? I set y equal to 0. Can I have more than 1 x-intercept? Yes, I can cross the x-axis as many times as I need to, but it isn't guaranteed to have an x-intercept. If I get those points and I get my asymptotes and I still don't know quite where to put my graph, how do I find extra points? Well, when I'm looking to find extra points to go on my graph, I'm going to pick values to either side of my vertical asymptotes. I can pick values to either side of my vertical asymptote. So if my vertical asymptote is at 1, I might pick 0 or I might pick 2. If my vertical asymptote is at -5, I might pick -6 or I might pick -4. Okay, so I want you guys to stop and I want you to try to work through at least one of these graphs before you pick back up and turn the video back on. I'm going to talk through my process of graphing these and hopefully answer any questions that arise that you find while you are graphing. Okay, So I'm going to think about factoring where I can. My denominator is difference of squares. It will factor out to conjugate pairs, but my function is in lowest terms. Nothing is going to cancel out, so there are going to be no holes in my graph. Those two values from the denominator are both excluded from the domain of my function. So my domain is going to be all values of x except -3 and +3. Both of those are going to give me vertical asymptotes. X equals 3, x equals -3. 1, 2, 3. 1, 2, 3. There's my vertical asymptotes. You know what? My graph looks like it's going to be centered around the origin y-axis, so I absolutely need to check for symmetry. So let's think about what happens if I plug in a negative x. F of negative x would give me a -2 over -x² minus 9. You know what? Nothing's going to change there. I come out with -2 over x² minus 9. When nothing changes, I have an even function, and it is y-axis symmetry. So that makes my life a lot better. Oh, no, that's right. Nothing changes because I have an even function, which is y-axis symmetry. I'm sorry, I was looking at the wrong key, and it was giving me an answer I didn't like. Okay. Horizontal or slant asymptote. To figure out whether I have a horizontal or slant asymptote, I compare the degree of the numerator to the degree of the denominator. The degree of the numerator is less than the degree of the denominator, so I have a horizontal asymptote at the x-axis. So I can go ahead and sketch in that horizontal asymptote. Now, because I have y-axis symmetry, I know my graph can be folded in half on the y-axis. So if I'm up on this end, I'm up on that end. If I'm down on this end, I'm down on that end. Same for the middle. It's either going to be both ends up or both ends down. It is not going to be one up, one down, because it's an even function. So that makes my life significantly simpler. Okay, now let's think about my y-intercept. My y-intercept happens when x is 0. So if x is 0, I need to plug in 0 for x in my function. I get -2 over -9, which is a +2/9. Where x is 0, y is a +2/9. That's just above that x-axis. Now think about this, guys. We just said we have an even function. Both ends have to even out together. It's going to be symmetric about the y-axis. So I expect that both ends are going to go up, and I'm going to be turned by that horizontal asymptote. Let's check a value just to be sure. Let's check maybe 2. Let's check x is 2. If x is 2, I have -2 over 4 minus 9, which is -2 over -5, which is a +2/5. Now, +2/5, positive is what's important. I am still above the x-axis. And because it's an even function, symmetric about the y-axis, I know both ends therefore go up. I don't have to check another point in the middle. Now let's think about x-intercepts. X-intercepts happen when y equals 0. So if I set my function equal to 0, 0 equals -2 over x² minus 9, I know my next step is to multiply both sides by that denominator. When I multiply both sides by the denominator, anything times 0 is 0, I get 0 equals -2. That is not possible. There are no x-intercepts, which is not surprising because we have a horizontal asymptote here. So what I need to figure out now is, are both of these ends up or are both of these ends down? And I'm going to figure that out by plugging in an extra point. I'm going to choose to plug in, this vertical asymptote at -3. I'm going to do -4. And what I'm interested in knowing is when I plug in -4, do I get a positive value or a negative value? It's either going to be my function is up here or my function is down there. And once I know this side, I know it reflects to the other side. So let's do x is -4. Where x is -4, I have -2 over -4 squared minus 9. -2 over 16 minus 9 is -2 over 7. which is negative. That's the important part of that. This point is going to be down here. And so this piece of my function is turned by those asymptotes down below. And because my function is even, it's symmetric about the y-axis, this reflects to the other side, and there's that remaining piece of my function. I should have brought that up closer into that corner. Forgive me. Okay, let's look at number 2. All right, think about factoring. Factoring would give me negative x over x plus 3, x minus 3. Again, still in lowest terms, so I have no holes in my graph. Same two values are excluded from my domain. Both of those have to be vertical asymptotes. X equals negative 3, x equals 3. So I'm going to sketch in those vertical asymptotes. Absolutely symmetry is possible, so I'm going to need to take a look at that. Guys, forgive me where my vertical asymptotes don't look straight. Pretend that they are. Okay, so let's check out symmetry. Let's see. If I plug in a negative x, I get the opposite of my numerator. The opposite. Negative x becomes positive x here. And my denominator doesn't change, so I get the opposite of my original function. Instead of a negative x over x squared minus 9, I have a positive x over x squared minus 9. So my function is odd, and that means it's symmetric about the origin. Ooh, that's good to know. Instead of everything going top, top, bottom, bottom, I'm going to have that twist in the middle. Either my ends are going to be up and down like this or up and down like that. My middle has to look like a cubic function. One end up, one end down. All right, let's take a look at that horizontal or slant asymptote by comparing the degree of the numerator to the degree of the denominator. Degree of the numerator is 1, degree of the denominator is 2. So it is less than. I have a horizontal asymptote at the x-axis. So this is going to give me a function because of that symmetry that crosses that horizontal asymptote at the x-axis. Okay, let's think about my intercepts. If x is 0, I get 0 over negative 9, which is just 0. That's also an x-intercept. I need to look to see if I have any other x-intercepts. To figure that out, I set y equal to 0, so negative x over x squared minus 9. Multiply both sides by that denominator. 0 equals negative x. I just get that 0. X equals 0. So that is my only x-intercept. That's the only place where I'm going to cross the horizontal asymptote. That makes sense. Okay, I got to do some extra points on this one to get my graph, because otherwise I don't know where I go. If I go start high, finish low in the middle, start low, finish high in the middle, if this ends up and this ends down, or vice versa. I know it's going to be that twist in the middle because of my symmetry, but I don't know exactly how yet. I've got an asymptote of negative 3. Let's check negative 2. If x is negative 2, then the opposite of negative 2 is positive 2. Over negative 2 squared is 4 minus 9. That gives me 2 over negative 5. So if x is negative 2, y is a negative 2/5, it's going to be down here. Because of our symmetry, because we have origin symmetry, I know that if this side goes down, the other side goes up. And I don't have to check any other points in the middle. I can just go ahead and sketch that out. I do, however, need to know what's happening with these ends, which one's up and which one's down. So I need to check either negative 4 or positive 4. Let's go ahead and check positive 4. If I plug in a positive 4 for x, that gives me negative 4 over 4 squared minus 9. Well, negative 4 over 16 minus 9 is 7. That's a negative 4/7. Negative, that's the important part. So at positive 4 here, I'm down below, which means this piece of my graph looks like this. And since I have origin symmetry, the other end has to be up because it has to be that twist. And that's what graph number 2 looks like. All right, graph number 3. x squared minus 1 over x. You know what? I haven't graphed a squared function in the numerator, so I'm going to go take a look just to kind of give myself an idea of what to expect. And oh my goodness, in my examples of rational functions, ta-da! Okay, so maybe I'm going to set that aside and not spend a lot of time looking at it because I want to work on it a little bit more and make sure I know what I'm doing. My function, the numerator will factor, but not the denominator. Nothing is going to cancel out, so there are no holes in this graph. The domain, the only value I need to exclude is 0. So that tells me that I have a vertical asymptote at x equals 0. I'm going to check for symmetry by plugging in a negative x. That would, if I plug in a negative x there, the numerator doesn't change, the entire denominator changes sign. So that's the same thing as the opposite of x squared minus 1 over x. I went from a positive x squared minus 1 over x to a negative x squared minus 1 over x. That is the opposite, so that is origin symmetry again. It's an odd function with origin symmetry, so that's helpful. Horizontal or slant asymptote. Let's compare the degree of the numerator to the degree of the denominator. The degree of the numerator is 1 more than, so I have a slant asymptote. And I need to do that division to figure out my slant asymptote. I need to do x squared minus 1, or minus 0x minus 1 divided by x. And then that's my remainder, so I just get y equals x. That positive diagonal line with a slope of positive 1 as my slant asymptote. Y-intercept happens where x is 0. X can't be 0. X being 0 is excluded from my domain, so there are no y-intercepts. X-intercepts, however, happen when y equals 0. So I take my function and I set it equal to 0. Multiply both sides by the denominator. So I get 0 equals x squared minus 1, and we already know what that factors out to be. So we get x equals negative 1 and x equals positive 1 as our x-intercepts. That gives us the structure of our graph right there. If I know my function passes through those 2 points, I can just use my asymptotes to turn it, and I know what my graph looks like. If I wanted to do extra values, I could do something else in here, but I don't need to. I'm good. All right, final graph, number 4. F of x equals x over x squared plus 2x. F of x equals x over x squared plus 2x. Let's take a look at what that's going to look like. We're going to start by factoring anything that will factor. I can factor an x out of my denominator, and ooh, that is not in lowest terms. So I'm going to stop right here, and I'm going to say, okay, for my domain, I need to exclude 0 and negative 2 both, because those are my 2 factors as presented. But that's going to cancel out and give me 1 over x plus 2 as my function in lowest terms. That value that cancels out, that x, gives me a hole at 0. So I'm going to have a hole at 0. I need to remember that there's going to be a hole in my graph there. Now let's think about symmetry. Do I have symmetry that I can predict? If I plug in a negative x, what happens? I can plug it into lowest terms, or I can plug it into my original function. It really doesn't matter. If I plug it in here, I can see that I have 1 over negative x plus 2. It changed part of the denominator, but not the whole thing. If it doesn't do the whole thing, it's not predictable. Okay, 0 was a hole, but negative 2 is a vertical asymptote. It's a value excluded from my domain that stays excluded even when the function is in lowest terms, so that gives me my vertical asymptote. So let's think about horizontal or slant. Compare the degree of the numerator to the degree of the denominator. The degree of the numerator is less than the degree of the denominator, so I have a horizontal asymptote at the x-axis. Y-intercepts and X-intercepts. I can't have any Y-intercepts because 0 is not in the domain of my function. X-intercept. Well, if I set y equal to 0, oh, you know what? I don't even have to do, I can do the simplified form. I can do 0 equals 1 over x plus 2. I multiply both sides by x plus 2. I get 0 equals 1. That can't happen. There are no x-intercepts. So I absolutely have to do something about some extra points. I have to try something. I can try values on either side of that asymptote, or I could try large values. It doesn't really matter. Let's do -1 and +1. I can't do 0 because 0 is excluded from my domain, but I can do -1 and +1. If I plug in -1, I get -1 over 1 minus 2, which is a -1 over -1, which is +1. Ta-da! So where x is -1, x is -1, y is 1. So you know what? That's going to go right there with a hole in my graph. Where x is +1, I have 1 over 1 plus 2, 1/3. Oh. Right? 1/3. Why did I do, oh, that didn't help me. I'm sorry, guys. I'm getting tired. -1 and +1 are both on this side of my vertical asymptote because my vertical asymptote is at -2. Let's do -3. That's going to help me. I need to get this side. X is -3. And I don't even know why I'm plugging into the big function. I can do the lowest terms function. 1 over -3 plus 2 is 1 over -1, which is a -1. Where x is -3, y is -1. X is -3, y is -1. That was what I was expecting. And I've got that term. Okay, I'm not going to redo the video because it's good for you to see me struggling a little bit too. When I went to go put it on the graph, I was expecting one up end up to be one end down based on the other functions that we have graphed. And I had to stop and think about what I'd actually found. I had found 2 values that are on the same side of that vertical asymptote. I only needed to have done one of those. The other one did not help me. I needed to do something on this other side of my vertical asymptote. So that's why I went back and did that -3. Don't get discouraged when you do something that doesn't work out quite the way you intended. We learn sometimes way more through our mistakes than we do by doing it correct the first time.